Alrighty, so this is the 2008 Form B FRQ. I gave it out last week. It's a gold piece of paper, so if you didn't get it, make sure to pick one in the back of the room, or um, it should be linked on Canvas as well. So take a look at it. But here we go. Here's the situation. A car manufacturer is interested in conducting a survey to estimate the mean stopping distance for a new type of brakes when used in a car that is traveling 60 miles per hour. These new brakes will be installed on the cars of the same model and a stopping distance will be observed. The cost of each observation is $100 and a budget of $12,000 is available to conduct this study. And the goal is to carry out in the most economic way possible. Preliminary studies show that S is 12 feet. Are there sufficient funds of evidence available to estimate the mean stopping distance within 2 feet of the true mean stopping distance? So this 2 feet, that is your margin of error because you want to be within 2 feet of the mean. So that's your margin of error right there. So let's go ahead. We can set up our equation. We know our margin of error is t star times s sub x over square root n. We want that to be less than or equal to 2. Okay. Go ahead and start filling things in. So t star, we'll leave that off to the side right now. S sub x is 12. We don't know what n is, so we leave that there. And it will be less than 2. Okay, so let's go ahead and get our t star then. So I want 95% of my data to be on the inside. That means on the outsides I have 5% total, which if I split that up evenly would be 0.025. So I'm going to go into inverse t. Area equals 0.025. And then I also need my degrees of freedom, which is n minus 1. And oh no, that is a problem I'm in right now because I don't know what n is, right? That's the whole purpose of what we're trying to solve. So this is not going to actually work, this method. So what we can actually do to actually kind of help us out here is, for right now, let's just make an estimate. We can approximate t, right, with the z distribution. It's not going to be exactly right? The z distribution, if I drew it on here, would actually look something like this. Right. But let's just take a quick peek at how they compare. So inverse norm 0.025, and then t inverse t 0.025. Let's even just say the degrees of freedom. Let's just say it's 30 right now. My inverse t obviously is going to be bigger, right? T has a bigger, right there. T has a larger margin of error than z, right? Or a wider interval. So z is actually going to be a smaller interval for us. So if we use z, that will help tell us if it passes or not. Because if it doesn't pass at z, it's definitely not going to pass at t because z is smaller. Now, if it passes at z, we don't know exactly. Like, there's a chance it could be right in the middle between those two, so we have to keep that aware. But at least we could start with z and see what happens. All right. So we're going to do a normal CDF. And when we did that, we got 1.96. So I'm going to replace that here. So 1.96 times 12 over square root of n is less than or equal to 2. So algebraically now, to solve this, I'm going to divide that 1.9 over. 2. Now, actually, I won't round it all either. I'm just going to make this positive because it doesn't really matter. That direction. So 1.02. And then I'm going to multiply both sides by the square root of n. Now I can divide by that 1.0204. Same thing. So now 12 divided by second answer, 11.76. I will then square both sides. 138.29. So that means n has to be 139. So now the question of do we have sufficient funds? Okay. Well, there's $100 for each trial to be run. Okay. And so take that 139 times 100. That's going to cost $13,900, which is not in our budget. So we do not have enough funds. All right. So this is a really good problem. I really like this problem because it goes through that idea of what you would love to do in stats. You would love to keep your margin of error within 2. However, not always possible to happen, especially when things cost a lot of money to be done. Or you could think about like taking the risk, for example. Like obviously this would be in a controlled environment, but if there's some level of risk with actually running the test, that could lead to some things as well. So in this case, we actually don't have enough money to run it. And so if we're not going to pass it, this is what I was saying before, if it doesn't work on the Z interval, it's definitely not going to work on the T interval because the T interval is going to be even wider. So that's one thing. I want to show you actually another way to do this problem potentially that one of your classmates came up with and told me about. Okay, let's go with this idea of seeing if we have enough money or not. Okay, so my budget is just $12,000. If each sample is $100, that means my sample size, the most number of tests I can do equals 120, because that times 100 will hit me my budget. So that's the most I can do. So let's just try and find our margin of error. So T inverse T. I'm just going to erase that. I'm going to get my T star out. That's what I was trying to write. T star equals inverse T. Area is still 0.25. My degrees of freedom now are, I know it now because I'm going to assume I can only do 119 or 120, so my degrees of freedom are 119. So here, second distribution inverse T, 0.25, 119. Paste. So 2.036. So that's my T star. That is not my T star. I didn't do that correctly. It should be 0.25. My T star is 1.98. Yeah, 1.98. So then I can get my margin of error out. Times 12 over square root of 120. To take that times 12 divided by square root of 120. I get my margin of error to be 2.17. That is greater than my margin of error of 2, so it does not work. So the same problem that we had before. All right, so there is that. So either way works. This case, so on the left-hand side, this will work for more general situations where you're just trying to find the sample size. Now, like I said, you can't do it for t when you don't know your sample size, so you would have to approximate it with z, which is fine. But this right-hand side was a special way to do this problem since they're specifically asking if you would stay under budget, so we can come up with a value for n to be. All right, so either way, we don't have enough money. Part B is just trying to ask you a little bit more about this. A regulatory agency requires a 95% confidence level for an estimation of the mean stopping distance that is within 2 feet of the true mean stopping distance. The car manufacturer cannot exceed this budget, $12,000 for the study. Discuss the consequences of this constraint. This is a little bit more up to interpretation or what you want to say, but you could just say simply, due to these constraints, we cannot meet the requirements of the regulatory agency. Now, that means two things, right? Either they need to better develop these brakes to drop your S sub x down more, or they need to spend more money and have a larger sample size, and that could possibly help. So that's an option as well. But in the simple aspect, they do not satisfy the requirements of the regulatory agency. All right, so there you go. That is the 2012 Form B, question 3.